All right, so these notes are about linear regression, and basically linear regressions is the introduction to scatter plots. So the first thing we need to know is the measure of correlation is a correlation measured by the correlation coefficient, which is lowercase r. And r, it should be lowercase, but r is the number between -1 and +1. A calculation called the correlation coefficient r is used to measure the extent to which the data of two variables showed in a linear relationship. So the closer to 1 and -1, the stronger the linear relationship. What that means is this. Let's say I had a set of data points, and let's say the points lie straight in a line. A set of points, they're all in one straight line. It's a pretty tightly knit line. That would be a perfect relationship. So in this case, r would be +1. So we'll say this is a perfect correlation. You're almost never going to get a perfect correlation. Usually something less than perfect. For example, let's say I had this data set. I had a dot here, a dot there, a dot there, a dot there, and dots kind of there, right? Looking at that, it's not a perfect correlation, but it does look like a correlation is happening. In this case, let's say this is representing the amount of money you spend to make a movie and the amount of money it makes at the box office, right? So you think a movie you spend a lot of money on, let's say Avengers, and should make a lot of money at the box office because, you know, you have bigger stars and better special effects. And if you spent little money on it, and theoretically, you're probably gonna make just a little money off of it as well. So this should be a pretty strong correlation. So we say this is a very strong correlation. And that's what it is. It's a very strong correlation. Notice how tight they are together. Now, suppose we had this data set. Suppose we had a data set that looked to be a positive relationship between the points, but instead of being super tight together, it's a bit more spread out. If these dots represent data, right? So instead of being super tight in a row, it's a bit more straight out. It's definitely still a positive correlation. You definitely can see that there's a correlation happening. So you can see that as we go out to the right, most of the data grows. So we say this is a moderate correlation. So moderate correlation. And suppose we had something like this. Suppose you had a data set that it looks like it grows, but just as often as it goes upwards, also kind of goes downwards, make that look a little bit more like it might be going in the same direction, but a lot wider. All right, so it looks like it's going upwards as I go to the right, but the spread is wider. So we say this is a weak correlation. The wider the spread is, the weaker the correlation is. So again, as we go up, it looks like it goes up as well, but some don't. So we say that's a weak correlation. Just for the record, a perfect correlation is r equals 1. That's a perfect correlation. Perfect correlation. If r is in between 0.75 and 1, we say that's a very strong correlation. So it's not really 1 and it's 0.75 or bigger. So it's a pretty strong, like 0.8, 0.6, 0.9. We say that that's pretty sure bet. That's a pretty strong correlation. Now the next set correlation is this, is for moderate correlation, r will be between 0.5 and 0.75. So there, the closer it gets to 0, the more spread out the data is. So this is getting closer to 0, and the data is getting more and more spread out. So that's somewhere between 0.5 and 0.75. We say that's a moderate correlation. And a weak correlation, it is a correlation, it's just weak. So we can't say it's 0. So something that's like 0.25 and 0.5. on this or equal to R. So R is in between 0.25 and 0.5. We say there's a weak correlation. Now, no correlation would look like this. If I gave you a set of data, and it was literally all over the board, we say that set of data has no correlation. As I go to the right, it doesn't affect whether or not these numbers go up or down. There's no relationship between the X and Y axis. So that has no correlation. Something like, let's say you had the price of gas in Mexico and the price of tea in China. They probably have no correlation. They're probably not related to each other. Probably have nothing to do with one and the other. So this is if R is between 0 and 0.25. Anything less than that, we say it's no correlation whatsoever. Now, if we go, that's all these are positive correlations. It works just the same if they're negative numbers. So I'm sure a list of the negative ones now. All right, so this example is clearly a perfect correlation. So R is -1 because it's a negative slope, because it falls as I go to the right, where these are positive slopes. Here, we say R is in between, it is bigger than -1, but it's not bigger than 0.75. So on -0.75. So we can go from here. This one, this is a moderate, this is a very strong correlation, very strong negative correlation. This is a moderate negative correlation, so that would be in between 0.75 and 0.5. It's -0.75 and -0.5. This would be moderate. So I add the labels to them. It's very strong, moderate, and then it was in between -0.5 and -0.25. We say that's a weak correlation. We say there's a weak negative correlation there. And again, no correlation would look the same either way. You just wouldn't see a correlation. All right, let's go back to the notes. All right, going back here, basically, you see that if on the negative side, we have a strong correlation, and then right around 0.5 or so, it gets really weak, all the way down to just weak, just none. And then it gets weak at 0.5 and below, and strong as you get closer to 1. So looking here, say which direction does it have? Well, we definitely have a positive direction here. Look at the next one, it's going downward as it goes to the right. So this is clearly a negative direction. All right, so we got 4 of these graphs here, and apparently it's going up in strength. So this is definitely a perfect correlation. This is perfect, because it's pretty much straight in the line. If I drew a line, pretty next, go straight through all those points. This is a very strong correlation. The strength is really strong because the line, that's pretty much in a line, almost. This is moderate, because if I drew a line, most of them are pretty tight to that line. Pretty tight and pretty close to it. If I drew a line through the middle of that data, most of them are pretty close to that line. They're not very far away. If I drew a line through the middle of this data, where it's like equal parts on each half, it looks to be a bit more spread out than the other ones, so we say this is kind of weak. It's a weak correlation. I'm going to say this too. My line might should go through here, a little lower. But yeah, it's still going to be a weak correlation. You want the line to go through where it goes through and is equal amount, or close as you can to equal amount on opposite sides of that line. That means that was the best line. So if you had the correlation coefficients, they went from something that's close to 0 on the left side, close to 0, right? All these numbers, this number gets closer and closer to 0, and this correlation gets close to 1, positive 1, because all those numbers approach positive 1. The next set of questions says, put the correlation coefficient in order from weakest to strongest. And looking here, my weakest correlation is something close to 0. So looking there, my closest one is 0 is 0.07. The next number up from there is 0.43. The strongest correlation out to 0.43 is negative 0.81. So Keep in mind, you're not talking about the actual number on the number line, but which one is closer to either positive one or negative one. And that's not as close to the positive one as the 0.87 is. So 0.87 is the next number up, and the last one is negative 0.98. So that would be that listed in order from strongest to weakest. So keep in mind, you think about the absolute value of these numbers. So not the negative signs on them, but the absolute value after you drop the negative signs off. So in the second list, the smallest number is clearly 0.04. So that's the weakest correlation. Almost no correlation at all, but basically no correlation at all. The next number up from there is 0.32. After 0.32, the next number up is negative 0.42. And after negative 0.42, 0.63. And the strongest correlation in this set is negative 0.65. So that would be the strength from least to greatest, weakest to strongest. Going here, it says match the correlation coefficient to its graph. So we're gonna find I'm gonna find the strongest one first. And this looks to be the strongest set. Like if I drew a line there, that's pretty much in a straight line almost. So this is probably negative 0.95 because it's negative and it's a very strong correlation. And looking around for the other ones, so I use that one, negative 0.95. This is basically no correlation, so 0.08. So the one with the weakest correlation is this. So this is probably 0.08. That has basically no correlation, and 0.08 says no correlation. So the next one down is 0.7. We gotta make sure the data set's positive. So the only ones that are positive are these two. And this is a pretty tight set of data. So this is like probably 0.8, 0.9, something really strong. So it couldn't be 0.7 because 0.7 is in the moderate category. If you remember, 0.7 is somewhere like this. It's a bit more spread out. They're not as tight together. So I would say this is probably 0.7. That'd be the strongest one. That'd be the best answer for that graph, that correlation. R would be about 0.7. You know what I'm saying? R in that case is this. R in that case is that. After that, so it's 0.97. Well, yeah, that's a great correlation. And this is it. This is 0.97. Because that's a really tight curve, really tight set of data. And the last one is negative 0.75. And this is a pretty moderate correlation, almost weak. So it's right there at it. So this is R equals negative 0.75. So we decided all the correlation coefficients by using what we know about it and taking a pretty good educated guess. All right, I think that's it. That's all I have. Good luck.